Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and Legit Security. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have another exciting panel for you today. First, a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, and this is going to be a webinar format that is highly encouraging of questions. So please, if you do have questions, send them in using the Q&A tab, which can be found on the right side of your screen. That's also where you'll find the chat tab, where we want you to get to know your fellow audience members. Let us know where you're from, or just maybe your thoughts throughout today's program. And of course, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic is how to shift security left, best practices from a Fortune 500 DevSecOps leader. And I'm joined by Bob Durfee, Global Head of Digital Experience and DevSecOps at Takeda Pharmaceutical, Liav Caspi, CTO and co-founder of Legit Security, and Alex Pavar, Software Supply Chain Security Advocate at Legit Security. So Liav, Bob, Alex, thank you all so much for joining me. Alex, I think you're going to be kicking us off. Is that correct?
That's correct. Thanks, Cody. And hi, everyone in the audience. On behalf of Legit Security, thank you for joining today, where we'll be sharing best practices around shifting security left. So today's webinar will be a conversational question and answer style format. Before that, though, Bob, who is the global head of DevSecOps at Fortune 500 company Takeda Pharmaceutical, is actually going to share a story about how building bridges between security and development might go in the real world based on his experiences. So Bob, on that note, why don't you go ahead and kick us off?
Thank you, Alex. Appreciate the opportunity to be here and talk about DevSecOps, and on to the story. So when I first started in DevSecOps at Takeda, I was reaching out to various application owners and talking to them about what we can do with their applications and so forth. And this one application group really stood out for me. And so I reached out to them and was having a chat with them about their application and what we could do from a pipeline capability, from static application security testing, software composition analysis, et cetera. And they were a bit, I guess, standoffish would be a understatement, to be honest. And they said, hey, we go through validations with the organization. We go through audits with the FDA. And they use this exact quote: "We don't need you from a security standpoint." And I said, "Great, I'm all for that. Would you mind if we just did a pen test on your app?" And they were like, "Please, yeah, we'd love to have that." So we reached out to a managed service provider that does application penetration testing and had a red team come and basically, to be honest, just abuse that application, and it scored the lowest that vendor had ever seen from a pen testing capability. And it was an interesting reaction. I thought they were going to be very taken aback by that, and I mean, they were a little shocked by the results. But what happened was they became one of our biggest advocates. They said, all right, we're all on board with this. We understand what you're coming from. The audits weren't catching what you were catching from a security standpoint. Let's go all in. And so they are one of our biggest proponents in the organization, basically a giant advocate for DevSecOps and building security into the application as soon as possible, rather than having to bolt it on later or backtrack and do some reverse engineering.
Thanks, Bob, for sharing that story. Never gets old for me. I like the nice ending. On that note, now that our audience is feeling optimistic that their development teams can actually become more security minded, let's shift gears into our Q&A. So from here on out, I will be posing a variety of questions to Bob and Liav here, who will be responding to those questions and also sharing some other insights they might have on that particular topic. We have several questions to run through, as Cody mentioned earlier in the intro. If questions pop up on your end, definitely contribute them to the Q&A. We'll run through the main portion of the webinar, And then we're reserving some time for the end to do questions ad hoc that the audience might have of Bob and Liav. So I definitely want to encourage that audience participation if again, you have questions you'd like to ask, something inspired by the topic at hand. On that note, let's go ahead and get started. So Bob, let's kick it off with you. Why don't you just give the audience a brief history of DevSecOps maturity over the years at Takeda?
Okay, thanks, Alex. DevSecOps in Takeda was very, very fragmented. Each application team seemed to have their own mindset, set of tools, methodologies for doing. I'm just going to call it DevOps. It wasn't really a DevSecOps. There wasn't a whole lot of security baked into this process, and so we had some Azure DevOps people over here. We had R&D maybe using the Atlassian stack over here, and we had some of the older guys using Subversion over here doing some Java development. And what we decided to do, and the reason my position was created, is we need something enterprise scale. We need something that the enterprise could look at and say, this is what we're going to do from a platform perspective, from a process perspective, from a tooling perspective, to make things easier for the developer. We talk about developer experience. Developer experience is crucial. We want to build, and one of our goals, one of our guiding principles when we started this effort, we wanted to build a platform that developers want to use. So they would look at their Azure DevOps and go, man, you know what? I think we get a lot more value if we switch to the enterprise platform. Same thing with Subversion guys, and same thing with the Atlassian people. You get a little bit of that holding on to that blanket that's very comfortable for them. But ultimately, once we started building our platform, once started getting things to happen, we started getting people to pivot from their existing platforms into ours, so we could do things like static application security testing, the software composition analysis, API scanning, things of that nature that really add value down the road. We also looked at, from a process perspective, we as Takeda often like to use the big four, whether it's EY, Deloitte, Accenture, PwC, and come in. But ultimately, we did get advice from one of those, but a lot of times these big vendors want to come in and basically just parachute in a solution. Here's your entire DevSecOps process and plopped it on your table. And that's not something we were really interested in. We were really interested in kind of growing this organically, learning as an organization, and easing our developers into it. We didn't want to go in and have code added to our platforms that were immediately like blocking merges if somebody had a critical finding. We just wanted to learn, get an idea of what we would see, and then ease into it. And I'll give you an example. One of the recommendations was, hey, OWASP top 10. Okay, block. If it's in the OWASP top 10, you need to block, preventing merges. And what we started to see as we gathered information, there was really three issues that we'd see consistently. One was SQL injection. The other was cross-site scripting. The other one was command injection. We called those the Takeda top 3, and we focused on those. And we really helped our customers and our developers come up with a way to address those issues. And we focused on those issues, got the process kind of lubricated and got it moving and made it work. And then now that we've done that with the top 3, we've now enhanced it to go, all right, let's go with the top 10. And so as we mature the stack, we also mature the processes along with it and enhance the security along with that.
Sounds good. So thanks for sharing that. On that note, I want to open this one up to both Liav and you, Bob, on so why remediate security issues in pre-production versus production? This is a shift left webinar after all. What do you two say to that? You both have skin in the game, so to speak, but from very different perspectives. I think our audience would really appreciate hearing both sides of that.
Okay, I'll take a crack first, if you don't mind, Liav. So when we talk about moving things, shifting security left, historically speaking, that's been from the application perspective. And by application, I'm talking about, a website or a mobile app or something of that nature, really not infrastructure. But we were talking about static application security testing and software composition analysis. So I'm going to keep using those phrases. But we see that a lot, and we're going to catch vulnerabilities before they get deployed because it's much easier to remediate. I can remediate that issue in code much quicker to solve. I just update this library. I've got just do an npm update or an npm audit -f and get a new version of that, and everything's cool. But we're seeing now on infrastructure. This is where I see the value is when we start adding infrastructure as code, whether that's CloudFormation templates or Terraform, things of that nature, where we have our security policy for the cloud says you have to have all EBS volumes encrypted. Okay. If we check that code, if we check that Terraform, if we check that CloudFormation prior to deployment, that's a 1-minute fix. If we have to fix an EBS volume post-deployment, that's a several-hour fix. Basically, you have to do a snapshot, detach the volume, recreate a volume with that's encrypted, and reapply the snapshot. It's ugly. It's not a fun solution as opposed to just saying encrypted : true in a Terraform module or a CloudFormation template. So that's where I really see the value of moving things left, is that you don't have these operational issues downstream, particularly on the infrastructure side.
Yeah, I totally agree, and I can continue to put my perspective on that. But I think it's also been proven. There are a couple of analysis that's been made, and say it's 10x cheaper if you consider the entire ROI of having something discovered later. I would place maybe two bullet points on that from what we see with our customers. One is obviously they want to get dev teams to be closer to security, kind of like you build it, you own it mentality. So it's a lot better that somebody is getting the vulnerability first into their life cycle, rather than having a report being sent to their email 2 weeks after something is in production. It's like this feeling of ownership. And then the second thing, I think it just stresses what you said, Bob, about there is a great opportunity now where everything is coded. Like another example would be, you don't need to patch manage operating system if everything is containerized and you've got the operating system defined in your code. You could validate that really early instead of scanning your network for operating system vulnerabilities, because you've got the definition of the operating system written in an infrastructure as code file. So I think there is greater opportunity to save costs and fix things earlier and save this patching or fixing production time, because there is a great shift in the recent years to codify everything and use a kind of like a definition language instead of procedural ones to all the infrastructure you get, and basically everything, even API configurations. So it's a great opportunity to just fix things really fast and even not deploy vulnerabilities.
Thanks both. So one of my favorite things that you said in prepping for this webinar, Bob, is kind of takes me 2 minutes pre-production, 2 weeks post-production. It's just the way the calendar days it takes to get something done once it's gotten more complicated and baked in. On that note, let's switch gears. Bob, was Takeda always doing this? So you've mentioned the value moving left, tackling these issues in pre-production. I have to imagine it took some effort. So was it something you were always doing? You inherited something great. How did you do it? What changes did you have to overcome?
Another good question. So yeah, it wasn't always that case. It was we have a lot of vulnerability scanning tools. We have Rapid7, we have Prisma, we have those types of tools that see things post deployment. And unfortunately, I think many large organizations are going to run into that same snag. Is you've got I use the phrase 18 and 18. You've got the apps that are 18 days old, and you've got apps that are 18 years old. And so how do how do you remediate those? How do you enhance the new and protect the old? It's those types of things that you have to do it once again in small chunks. As you start building some of these new applications, you can start putting that capability in there to start shifting left, to start catching these issues prior to go live. And as we bring it, as we notice that we start bringing in these other applications from Subversion or Azure DevOps or Atlassian, we start bringing those into our stack. We can start seeing vulnerabilities in that code. And so the next time they go to do a pull request, or the next time they go to do a push to production, we can start enforcing. Okay, you've got a critical vulnerability in this particular module, and Log4j comes into play when I think about that. Seeing when Log4j came out, we had a lot of new apps and a lot of old apps using Log4j, and so the new apps that we had in our pipelines, we were able to catch, and we were pretty draconian about it from a DevSecOps perspective. We were saying, guys, you either merge the fix in, or we're going to merge it for you. We're going to generate a pull request and just merge it in. You've got 48 hours to merge it in. I don't mean you have to push it to production in 48 hours, but you've got to put it through your test. You got to start testing this within 48 hours. But we also had a lot of things that were deployed manually, whether those were appliances from vendors or whether those were applications that were stood up via the console, things of that nature. So you still have to, handle the new and protect the old. So in a way, you still have to have the capability of that shifting left, that standalone mechanism that you can use to grab the new vulnerabilities before they get deployed. But then you also have to have the cloud security posture management tools, whether that's Wiz or Prisma or whatever people are using, to see what actually is there. This is what's reality, and this is what you're planning on deploy to reality. So you really have to catch it on both ends, and that's what we ended up doing. Fortunately for us, that movement is still more towards the left as we start refactoring these applications, or we do what we're called the journey to the cloud is what we have. We taking these things from on-prem, we codify the code used to generate that infrastructure. We start running it through our tools, and then we've got it. We don't have to rely on scanning from a Rapid7 or a Wiz or Prisma or something that tell me we got these vulnerabilities.
Great. And so related to this, we're going to kind of run through, just so the audience is aware, kind of like a related series of the next 3 questions, including this one. We'll start high level here for Bob and Liav to kind of share their thoughts. But then there's kind of 2 specific subcategories that we'll lean into that are a little bit more kind of tactical and tangible. So high level, Liav and Bob, what advice can you offer to AppSec or DevSecOps teams to overcome what are now insecure development practices that maybe weren't 5 years ago or 10 years ago, that sort of thing?
Okay, I'll take a crack at it again, Liav, if you don't mind. What's happened historically speaking is people tend to work in those silos, and nobody's going to see this application from the outside. Why do I need HTTPS even? Or I'm the only one who's going to be having access to this server. Why do I need to protect my secrets in my web config file or something of that nature? And that's, I'll call it back in the day, it really wasn't an issue. Now you've got cloud environments where if something's not protected just right, your EC2 instance is getting converted into a Bitcoin miner in 5 minutes. Okay, so you really, really have to be careful about, the adversaries have gotten so skilled. I mean, our adversaries have their own help desks now for, if you're talking about, issues that they're creating, and ransomware. That's the one that was coming to my mind. The ransomware teams have their own help desks now to help people deploy ransomware. So our adversaries have gotten way more skilled. And so we have to look at security from that aspect. And we didn't have to look at that, I'm going to say 20 years ago, not at all. 10 years ago, yeah, we had to, okay, it started opening itself up. Okay, we really need to start focusing on it. Now it needs to be absolutely key into whatever you're doing. Whether you're building infrastructure, whether you're writing an app, it doesn't matter. You've got to have security in the forefront or it's going to come back to bite you. Liav, would you like to add to that?
Yeah, maybe. Yeah, Alex, you said the question was like, what's the new insecure practices? So I think, like, building on the cloud example, I would say my point would be CI/CD, for example, which is something also new that's being pushed, and teams are creating an automated pipeline to push things. So if you think about it, cloud security solutions secure your cloud infrastructure from the outside, so nobody would hack it, or vulnerabilities won't be exploited. But you've got kind of like a highway to your cloud coming from your CI, changing the things there. Even the cloud configuration itself, hundreds or thousands of times every day, depending on the size of the organization and the apps. But this is a risk that you could ask yourself, like, how can I be sure that I'm not removing my authentication module in my app by mistake? Or how can I make sure that I haven't introduced the old log4j vulnerable component all over again, which all the world is trying to exploit right now? So I think when we see organizations, they're trying to rethink, eventually they have a code factory. It changes the cloud all the time because new versions are being deployed. And we're also deploying internally in Legit dozens of times every day. So I think there is a need to place a lot of guardrails and a lot of security before you deploy something in an automated fashion, so you don't even you don't do a small mistake, like exposing an S3 bucket by mistake. And a lot of mistakes happen. I think it just makes the mistake happen faster and automatically. So yeah.
And correct me if you think I'm misstating this, but it feels like the chaining of these different risks is also something that's becoming much more commonplace, right? Like I took advantage of lack of MFA into my source code management system, got my foot in the door. Well, now all of a sudden I kind of on the inside, and there's all these internal apps that I have access to, and then different risks there, which will tee us up for our next question to dive a little bit deeper into the details. Should internal apps have similar security requirements to external apps? There's a lot of, I think, leftover thinking from 5 years ago that, hey, I'll go secure like the production environment. But as Liav was saying, there's now like this automated highway into that, which means a lot of things from a risk perspective. So I'll open it back up to Liav, to you and Bob, to maybe kind of share your thinking on internal versus external. Like does that differentiation even matter today?
Liav, I'll let you go first on this one.
Yeah, actually, well, definitely there needs to be a different set of requirements, because you shouldn't treat any defect or vulnerability the same if you want to focus on what's important. But I would say it's a challenge. Like the 18 days and 18 years analogy is a challenge. Specifically also because a lot of the security tooling today is focused on specific technologies, and sometimes it's even hard to find tooling that would cover old or different, not cloud native type of resources. I would take this to things that we see from our customers, and I'd love to hear maybe your opinion, Bob. But definitely anybody needs to customize their, the threat model they're putting on apps. And one point I would make around that is that today there are a lot of issues. If you turn on container scanning at any point, just point blank, you'll get 3-4 digit number of vulnerabilities in even the new latest image. So I think, in my opinion, it could be also kind of like what's to focus on first. And then every organization that's going through some maturity level, from our experience in application security, go through the need to enrich data on the findings they have, which would represent the business criticality of the app itself. Like, is this app a production app, or is this thing an internal thing? So kind of like enriching things, and I think this is also where security products are going as a general. Like the CVSS, for example, which is a cool number, doesn't mean a lot if you don't know what it applies on. It could be, 1 could be super critical and 9 could be nothing if you don't know what apps it's applied on.
I'll add to that, Liav. From Takeda's standpoint, we try to keep from whether it's internal or external, we really don't. I don't want to say really don't care. I mean, from a pen testing perspective, yeah, any external app gets pen tested by default. But if it's an internal app, number one, it's a little bit more difficult to pen test with a red team, internal apps. But it really goes on a scale. If it's an internal app that's showing the lunch menu, it's going to have way less security requirements than something that's maybe showing some small molecule information from an R&D a site. So, but that being said, there's a minimum level that we're going to require, that and things that HTTPS. If you're making LDAP calls, LDAP-S, nothing, no clear passwords, no passwords in code, none of this stuff. Whether it's internal, external, there's got to be some bare minimum that you have to meet. And then from a friction perspective, and I'm going to use that lunch menu perspective, or that lunch menu example, from if somebody needs access to the lunch menu, great. All right, I'm not going to challenge you for MFA or something like that. But if you need access to something in R&D or some small molecule information, yeah, you're not only going to get challenged, but we're also going to look at other factors about you, and basically make a risk determination to say, all right, is it just not MFA, but you're coming from an IP address that's not known to you, and so we're just going to block this for now, and then you need to open a ticket if you need to get access. So even and one more thing to add on that, the area between internal and external is really starting to gray. The network as we know it is no longer, if you're using tools like Zscaler and you're not using VPNs anymore, you're using a lot of SaaS apps, or you're using Zscaler and the pandemic really brought this to the forefront, is that you started overwhelming your VPN platforms. So you need to, I'm going to keep using the Zscaler example, but there's other vendors that provide the similar solutions. But using those technologies blurs that line between external and internal. And so from a security perspective, you really have to keep that in mind when developing your applications. So just wanted to put that out there as well.
Thanks. Yeah. It sounds like one of the core takeaways is like not thinking so much on the technology, think more on like the criticality to the business itself. On that note, there is this kind of old way of thinking, new way of thinking shift. So I'll pose a scenario to you two here. This is kind of the last of our kind of series of related questions. So you've got a dev team, it's pushing back on a security requirement you're trying to implement. There's a specific ticket for something like a hard-coded secret. And it's in an internal app, and they're pushing back because 10 years ago it wasn't as big a deal that he hard-coded secret into that internal app. One of my favorite quotes from you, Bob, is the "you can't think that way anymore" phrase you like to use. But in this particular scenario, what do you do as a DevSecOps leader? Liav, what are you seeing our customers do to kind of help solve these problems?
Yeah, from our standpoint, we really try to educate and let them know that those, as I mentioned and for the previous slide, is that gray area of what is internal anymore. There's also the concept of zero trust. You have to assume that an adversary's inside already. And so, if you want to prevent lateral movement, if you start putting secrets in clear text in your app or in a web config file, I don't want to say you're asking for trouble, but you're not keeping honest people honest. You really want to, hide those secrets, encrypt them, put them in some type of privileged access management tool or some secrets manager, or there's a plethora of ways to keep that secret from being exposed. And so the fact that it's internal to me doesn't matter. There's a little less risk to it, but what's the issue is not necessarily the risk of somebody seeing it. It's the consequences if somebody does see it, because lateral movement becomes a big issue at that point, where if somebody gets a password that maybe has account operator permissions on a domain controller, all right, it's game over. You're going to be in big trouble. So I think most of our developers understand that. We try to make them aware of, generally speaking, keeping secrets in a config file or a properties file, or hard coded in your app even is generally speaking a bad idea.
Yeah, I agree, and I think specifically for secrets, usually it's something that usually developers get, and it's even getting to their sense of bad code. But yeah, every time there's been a breach on development infrastructure, the first thing that happens, they steal code, and then the next thing that happens, they steal passwords. So that's always, if you analyze incidents that happen, that's always the attack chain. And it's a big problem, specifically because once you touch your source code management system, it's there in Git history. And we've had countless number of customers that have made something open source and then realized that something was in the history. And this is actually something that's a big area for mistake. Sometimes even developers think they deleted something because they just committed the fact that the file was deleted, but it's still there in the history. And when they push, everything is synced. And then if it being made public, and we've seen this happening a lot. We've seen organizations try to take something public because they want to open source something, or even make it public within the organization, so everybody with a network activity could just access the code, or including the janitor. And then they forget the entire history is there. And secret is specifically even a problem because removing it is very hard, because you both need to change your code with a different kind of architecture. You need to, like Bob said, you need to use a secrets manager, inject an environment variable somewhere. So it's sometimes fixing the hard-coded secrets is a much more effort than the actual task the developer had to do. And removing it from history is super, super hard, because it's kind of like changing a block in a blockchain. You need to change the checksum for every commit, and it's a very aggressive operation. So secrets is a problem. And maybe one story about shifting left that, we do have a feature where you could review the pull request for secrets. But somebody who has just listened to that last sentence would say, doesn't matter, it's already pushed. Why would you review this as part of a pull request? Because pull request is done on the server after the code is there. But we find it useful because it speeds remediation, because developers sees immediately that they have hard-coded a secret into GitHub, and then they know they need to fix it before, and then they go through this process of removing the top commit and fixing it. So I think the explanation needs to be clear in order to get them understand that, and I think they need to understand the risk. I would also make another point about, like Alex, you said, teams pushing back security requirements. This is a big risk. I've seen this happening in my previous role in Checkmarks, because this is like an area, the trust between security and developers. If this is breached for some reason, if the security team is telling developers to fix something that it's actually makes no sense, then this can lead to the breach of trust, and then it's a loop or a snowball that it's really hard to then fix, because they'll then mistrust anything else. And so you need to make sure that this secret is a secret, or there is a good reason why you want to remove this thing, or it's not revoked anymore. There are a couple of things that sometimes needs to be tested before, but as a general comment about the need to clarify why something is important. And if you even if it's important and you leave it hanging and you don't explain that, it can also cause this mistrust.
Thanks for sharing. Before we move on to the next question, I want to add on to this one just a little bit. So, we have this explicit example of hard-coded secrets. And what I heard from both of you, Bob and Liav, is the kind of the need to educate. In this particular instance, it's not too hard to understand why, hard-coding secrets in clear text can be a problem. That said, if you're listening earlier, there's this concept of, continuous releases and CI/CD pipelines. And there is this new, well, it's not a new practice, but there's this new kind of extra risk now of calling at latest, at master, not verifying these third-party executions, before running them. So in this particular world, where a developer perhaps is less familiar, it's less obvious, like what the risk is. Do you adjust your approach? Is there any kind of specific guidance as we kind of, move into this continuous release age that you can offer to the audience on those?
Yeah, I'll throw in my 2 cents on that. We develop a lot of apps that are, FDA regulated. They are GXP applications. So the entire, software bill of material needs to be accounted for. However, when we were talking about the software development lifecycle, we use GitHub. We use GitHub Enterprise Cloud, and we use GitHub Actions as our CI/CD mechanism. And so workflows inside of GitHub Actions can call what's called an action. And those actions can be built by a number of people. Like anybody really can build an action. And some of those actions get updated quite frequently. If I'm building a GXP application where I need to know exactly what's happening as part of that process, I want to make sure that the action that I'm using to deploy to production that I'm using as part of the build process is the same action I went through my quality assurance testing and my development processes with. I don't want to be just using @master because, as SolarWinds showed us, really you don't know what's happening in between those commits. Unless you're going out and inspecting that code and looking at it and going, all right, this is the code that was changed between this commit, and this is what's currently active. So if you just use @master for some of your GitHub actions, it could come back to bite you. I'm not saying it will, but it could cost you hundreds of millions of dollars. So there's a good best practice to say don't use @master. When you are using a GitHub action, use a particular commit, a SHA-1 key that's associated with that particular commit. Use that and integrate that in. That way you're guaranteed to know that when I built this in QA, the same build process is identical to what I'm building for production. And that, it just helps from the sign-off perspective, makes the auditors happy when they see that type of implementation.
Yeah, I can just reiterate what you just said. If you imagine do you have a CI/CD to the cloud, then relying on the @master or the latest version of, let's say, a GitHub action or an image means that somewhere in the world there's a project, could be managed by a kid, that when they introduce code, it's in your cloud immediately. So you can you opened up your CI/CD kind of like a wiring into the cloud with absolutely no checks. And then, it could be, you need to kind of zero trust any component. And there are a lot of things that we see that are kind of supply chain attack surfaces. Using @master is one of them. Downloading a lot of the tools today, some of them, they stopped doing this, but they used to provide one-liners. This is how you invoke our tool, which is same concept. It's like wget latest pipe bash or things like that. And this is how CodeCov, for example, CodeCov customers ended up being compromised by CodeCov's supply chain attack, where their latest version was replaced, and then everybody running this one-liner ran the version. And if they were smart and introduced kind of like a checksum check in the middle there with a known checksum, or just downloaded it beforehand and updated it once in a while, they weren't. So there are a lot of, I think, as we go to modern development, the entire set of third parties in the world globally is kind of like a big ball of spaghetti where a lot of the things are interconnected. And there is absolutely no way to understand to what extent a component is going to affect something, because everything is really connected, and other projects that you may rely on the latest version of something. And it goes on for for a big, like huge tree of connections. So I think the best tip would be just first of all find all these doors, all these attack surface points, and then make an educated decision. I've seen companies that decide that to rely on the latest version of Microsoft because they say, well, we want to get security, and that's a valid maybe discussion to have. But if it's a project that's unmaintained, kind of like an abandonware or something like that, then I think it's a no-brainer to decide just to place a specific version that you trust.
Great point.
Alex, you are muted.
Thank you. On that note, let's wrap up with the last question of the kind of main portion of our webinar. We do have a few questions in the queue that we will have some time to get to. Bob, you shared a couple different developer personas with us, that like the way you think about engaging with development. I thought that might be super valuable to this audience. Why don't you help them understand what you mean when you're saying service level minded developer versus a security minded developer, and even like why you create these kind of two personas in your experience in DevSecOps.
Okay, well, I'll say, hopefully I'm not dating myself too much when I say this, but some of the older guys like yourself tend to be service level minded, and what I mean by that is you've got your backlog in Jira. You've got you've got these latest items you need to work on in your particular Scrum that you're taking care of. So you're focused on getting X done, and so you tend to say, I'm going to focus on getting X done. I'm not going to worry about security so much because it's going to take too long to do X. And these security-minded developers are really going, you know what? I can't focus so much on the service that I'm providing, because if something happens from a security perspective, it's going to come back and if not only affect me, but affect the organization. So a lot of the, I'll call them newer developers that I run into, tend to have a security mindset first. They tend to think about what's the impact. They almost do their own threat modeling in their head as they're doing things and go, all right, what's the consequences of me doing things a certain way? And they address those very quickly. And historically speaking, we as developers haven't really had to do that so much. We really haven't had to think about what are some of the vulnerabilities that somebody could take advantage of in our code that we're developing. I mean, that's, if you go back into Windows vulnerabilities with memory overruns, none of those guys were thinking about, oh, who cares? What's going to happen if somebody overruns my buffer? Okay, well, guess what? Some really, really bad things can happen, and that's nothing. I'm not saying anything bad against those guys, but you don't think of it. So those I call those service level minded developers are focusing on getting something done, something pushed out, and you don't think about the ramifications of something that could happen. And so I'd say kind of the newer people who have been impacted by security events are well aware of the impact of security, and so they tend to think more of a security-based mindset when they're developing apps, and it's actually quite refreshing to see when somebody comes to us and says, "Hey, what can we do to help our security posture for this particular application? Help us do some threat modeling. Help us do X," and it's a nice thing to see.
Yeah, totally agree. Coming from a security company ourselves, we're trying to push that, and I think we'll get it. But I totally agree with this. I want to shift to security minded. I've seen places where there was kind of like the attempt to create metrics. So there's been kind of like a gamification of security. I don't think it's. I think it's hard, but it's one way to get it. But I think it's clear the industry is pushing towards security-minded developers, and it's been proven that this is where you want to go. It's kind of like I think a essential component of the shift left approach.
All right, great. Well, thanks so much, Bob and Liav. For those in the audience, we'll shift gears over to kind of the more ad hoc Q&A. Like I said, we had a few questions in the queue. We've got about 10 minutes left to address those and any others that you might ask. Cody's actually going to run this last section as the moderator. So Cody, I hand it off to you.
Thank you so much, Alex. So our first question reads, how do you judge the success of DevSecOps and report it to your stakeholders?
Oh, I'll give that. We actually have a good metric for that, and I'm glad you brought that up. So what we do is we have a list of applications that go through our CI/CD pipelines and our DevSecOps processes, and we have a list of those that don't. Somebody may be still using the Azure DevOps platform, or they're using Atlassian or whatever, and we pen test quite a few of those applications. So what we've seen is the ones that go through our DevSecOps processes have way less vulnerabilities that are encountered via a red team. In fact, what made me feel good is our first application that went through our processes that was deployed externally in our organization. We pen tested it and had 0 vulnerabilities. There was the red team found nothing, and that was a very exciting metric. And so that's how we provide the benefit and provide the KPIs to my boss and to his boss, and say, this is the value we're getting out of DevSecOps. Not only we're getting the velocity of having a CI/CD pipeline, but we're also getting the reduction in vulnerabilities prior to a pen test. Because typically we'll get a pen test, there'll be 10 vulnerabilities, and then they have to go back and rewrite it in their pipelines and not catch it. So it's a lot of rework if they don't use our processes. And that's been a big plus for us, in the sense that we get more people starting to use our pipelines now, because they're like, wow, you guys are doing something right from a security perspective. Can we play in your playground? Absolutely.
Excellent, thank you. Our next question reads, can you walk me through your remediation process or workflow for a specific risk? And then the example is hard-coded secrets.
Hard-coded secrets. So we get a report of any repos that have exposed a hard-coded secret. And let's just talk about internal repos. Let's not talk about public repos. That's a whole separate aspect. But you know what? I might even address that in just a minute. But the remediation process there is, we reach out to the developer and say, you've got exposed secrets. So number one, depending on the type of the secret has to get rolled over. We basically have to rotate that secret and generate a new one. That's number one. Number two is, we need to find a way to no longer put that in code, whether that we put that into GitHub secrets and flow that through a CloudFormation template into production, or whether we use Secrets Manager, or whether we use CyberArk, or whatever we have from that perspective. So pre-deployment is one way of doing it. Post-deployment, it gets a little more difficult, but we did have an instance where a developer who worked for a third party cloned one of our repos and then created their own repo, and it was public, and it had an AWS key, a live AWS key in it, and it went into their public repo. The remediation for that is way different. And what I mean by that is, within 10 minutes, that developer was on a conference call with about 5 of our security guys going, all right, AWS contacted us, said they have a live key in the wild. This is what's going on, and this is what we're going to do to fix it. We are, number one, immediately making your repo private. Number two, we're rotating the key. Number three, we have to show AWS that we're providing steps to no longer do what we're doing. So I know that AWS takes that very seriously. I know that Takeda takes that very seriously. So public repos, that usually gets remediated within a 10 to 15 minute span. If we're talking about private repos, it's more of a carrot than a stick. But that would be an example. I hope that answered your question.
Hey, Liav, it might be worth chiming in too on how kind of visibility helps as a prerequisite to that, to have that context, and just some of those early co-founding conversations you had with CISOs about the problem they were seeing in regards to just getting the visibility across those supply chains.
Yeah, I can mention a few facts. So first, like Bob said, you can make the test yourself. There are a few tests made. They put a key which could only be usable to log in, and you want to test how long does it take for someone to use it. And I think the timing is something between 7 to 15 minutes if you play something in public GitHub. So in that respect, you really need. Sometimes you can rely on vendors. I think GitHub does that for specific, recognizable type of keys, and Amazon are doing this. But you really need to be alerted as fast as possible. And I've seen sometimes situations where the key wasn't there, explicit, regular expression you can catch, and sometimes, God forbid, it could be just sensitive data that you even can't roll back, like list of credit cards or something that is completely like something that if it's exposed, it's unrevocable. So hopefully this doesn't happen to you, but speed on that regard is really important. And then I can touch a problem where you scan all your code bases, you'll see lots of secrets. And they're sometimes, huge numbers. So there's sometimes a problem of what's more critical to fix first. So when you know everything, it's also a problem. And then things like checking what's valid or prioritizing. So there are a few things that if you think about them, a little bit more, you'll realize that, for example, SaaS application keys like Amazon are immediately usable when they expose. So you want to fix them first, rather than fixing first some ambiguous blob that looks like a password.
All right, so at this point in time, I'm seeing one more question. So to our audience, send in your questions. We do have a few more minutes allotted to address them. So this one is specifically for Bob, and it looks like it came in a little bit earlier on in our program. But Bob, why did you think your teams were originally standoffish? And then the asker asks if it was more of a matter of speed versus security, or kind of what was going on there.
Yeah, I'll be perfectly blunt. I don't think they were aware of what security vulnerabilities they had. And I think they were confident in the fact that they were being audited. I think they were confident in the fact that the system was validated, which is a very specific life sciences term. And they didn't consider the fact that, yes, you had what you said you had. That's fine. That's what an audit tells you. But the audit doesn't go out and do penetration testing. And then once the pen test happened and we found, SQL injection, exposed API keys, it was quite eye-opening for them. It wasn't anything malicious, but I think they were overly confident in the fact that they had all these controls around their application from an audit and validation perspective, that they didn't understand there's this third eye coming down and looking at it from a different perspective, and that perspective was a vulnerability perspective, and they just didn't consider that fact. Once they realized that that's their game on, they were all in.
Excellent. So we have exhausted all of our questions at this point in time. So Alex, I didn't know if you had any closing remarks or if we wanted to kind of go around the table one more time before we close out. You're muted.
Didn't click right. All right. So thanks everyone for your attention. I hope this was valuable to you all. Again, on behalf of Legit Security, and thanks for attending. Thanks to you, Techstrong, for hosting us. Liav, Bob, do you have any last words? I think the only thing in my mind is there's these kind of more traditional tools, SaaS and SCA, that everyone's familiar with. Being at Legit Security, kind of see this new wave of software supply chain security tools. So I do want to kind of give a call out and some attention to that, as there's this kind of new category of problems that existing tooling and solutioning isn't quite helping out with. But yeah, with that, Liav, why don't you go first, and why don't we wrap it up then with you, Bob?
Okay.
And then Cody, any housekeeping items that you need to do before we wrap up?
Sure. So very quickly, there's, historically, and Bob knows it better than me, a lot of security tools that have been bucketed into techniques, static analysis, SCA, dynamic DAS. That there are a lot of tools that can surface vulnerabilities. I can say that Legit Security and other products are all filling some gaps in few areas, but one particularly is visibility into how software is assembled, in the sense of where are all the code repository, what's the infrastructure, the users. So like there's understanding that there are a lot of components that make up your software. That's not only the source code you write. And we mentioned here a few of the risks, but along the process of producing and deploying software, there could be a lot of risks that you can expose your pipeline to, or even discover, like secrets is, for example, we talked a lot about secrets here. It's a data protection problem. It's not an SQL injection. You won't get hacked because your app won't necessarily be hacked because there is a secret in the source code, but your password would leak and your organization would be breached. Same thing is, relying on a third party in an unsafe way. You're opening your pipeline for attacks, or leaving an admin contractor too much permissions on your repository even after they've terminated their work. So there are few things like that, and I think that the key there is about getting complete visibility into all the components that make up software, plugins, and people, and all that.
Right, and I'll add to that in the sense that the tooling that we're talking about provides us insights into things that we typically don't have insights to. Like we've got a misconfigured repo. We can push directly into prod. Any developer in that repo can push directly to the production branch. Okay, and obviously that's something you don't want. You want to make sure that branch is protected. You want to make sure that you don't have 50 admins in a particular repo, or that you have 90 organization admins. Obviously, I'm making these numbers up, but it's the tooling can provide insights into the way your pipeline's configured. Not just, it doesn't look at just an app stack, or it doesn't look at my libraries that I'm implementing. Basically, it looks at the bigger picture and says, how is my software getting from A to B, and how am I protecting that mechanism, rather than just say how vulnerable is my software? Well, how vulnerable is my tooling that I'm using to build this software? And I think that we get insights into that, and it's a very valuable thing. You can take a look back at, after I do a build or I create a new repo, we'll take a look at it and go, oh, we got some issues here, and address those very quickly. And that's the whole point of shifting left, is the fact that we can catch these things before they cause a problem. I hate to see things in production where they come back and go, oh, this was because we have a supply chain problem, or this is because we've got a secret exposed, or this is because, oh yeah, this guy accidentally pushed a master. Okay, that those are big deals, and we don't want to get those. We don't want to catch those after the fact. We want to stop them from happening before they happen.
Well, all right, Bob, Liav, Alex, thank you all so much for joining us. And Alex, thank you for keeping us on track today and on time. I really appreciate that. So to our audience, this session was recorded. So following this, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the Security Boulevard website at securityboulevard.com/webinars, and just be sure to look in the on-demand section. So we have those 4 winners of our $25 Amazon gift card drawing. Our first winner is Alvin F. Our second winner is Mike P. Our third winner is Nordia G. And our fourth and final winner is Mastane P. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim that gift card. But if you don't find that email, just check your spam folder. A huge thank you to Legit Security for sponsoring today's webinar. And to our audience, we really appreciate you spending time with us today. We ask for one extra moment to fill out a brief post-webinar survey that will pop up on your screen as soon as we close out. But otherwise, we do hope to see you at an upcoming Techstrong learning program. Everyone, have a great rest of your day. And to our panelists, thank you once more.
Bye. Thank you.